electrodes and individual electrodes, and it can be porous or a solid. When second model is a homogeneous model, where you are not taking the heterogeneity of an electrode, but you're homogenizing and modeling it. And third is you're kind of lumping the entire electrode as a point, so it's called a single particle model. And then like if you really want to model as a circuit based and a lumped model, you're not interested in each and every electrodes, then it's called a equivalent to circuit or a lumped level models. So accuracy, of course, decreases. The amount of information you can get out of the simulation model decreases as you move from heterogeneous to homogeneous to single particle to equivalent model. These are different approaches. You can model the cells, electrochemical cells, whereas the speed increases. So because if you suppose want to model a battery pack with hundreds of cells, you cannot go with the first approach because it will take too much time and effort to simulate any or get any meaningful data out of it. So then you typically go for the lumped models or particle models and so on. But when you are designing a single cell, you want to do it as a heterogeneous or a homogeneous detailed models. So it's a trade-off between the accuracy and speed, what you want to do. But all these models and approaches are typically there and available in different simulation tools. Moving forward, again, if I talk about the scale, so that typically there are three scales. First is the detailed electrode modeling, where you can see the heterogeneous 3D model of a lithium-ion electrode. Second is a cell scale, where we model typically Newman model, 3D model for a lithium-ion cell. And third is a battery pack, where the different cells are there and they are connected, and you can do different type of flow and heat analysis, assuming the electrochemical heat source. So these are different scales which all are possible in different tools. The different tools have different capabilities. Right now this presentation is tailored for COMSOL, so at least in COMSOL you can model the micro scale, cell scale, and pack scale simulations. Now going a little bit deeper into like how are we modeling these electrochemical reactions, right? Because that is the core basis of it. So which is also called the battery chemistry for different type of cells. So talking about the Newman model for lithium-ion cells, you can see this is the snapshot from a COMSOL interface, and it has a physics interface called lithium-ion battery. It has a porous electrode as a feature, and here you can see all the equations which are being modeled, or which is actually the Newman model for lithium-ion cells. So through this feature, you can model the lithium-ion cells. Moving on, suppose you have an IMH battery with binary electrodes. So there's a different physics interface available. I'll not go into the detail, but you can see as a porous electrode feature, and on that you are specifying the electrode kinetics here. So you get to enter a lot different parameters about reference exchange current density, anodic transfer coefficient, and so on. And once you give all this input, which means you're specifying your cell chemistry and the parameters, then you can simulate and see the results, how it's performing. Along the same line, you can model, this is the model setup for vanadium redox battery, which is typically done using the tertiary current distribution Nernst-Planck interface. And these are the equations you can see here. Again, I don't want to go in the detail here. And this is a setup for the lead acid battery, which is, again, there's a dedicated interface for that. And what we need is, again, a porous electrode feature. You can see the electrolyte properties can be entered here and equations can be seen. So this way, you can basically model individual cell level chemistries and electrode kinetics, which are the basis for any cell or a battery. And irrespective of what type of cell is this, whether lithium ion, lead acid, or any other cell, everything can be modeled from the first principle, and then you can do the any other pack level analysis, which is heating, fluid, or vibrations, or any type of failures. So these are some other common battery chemistries available. So again, to re-emphasize, there are different fidelity models can be done, like high fidelity model, which captures all the details. Excuse me. So that is a heterogeneous model. And then you can have a homogeneous models where through different techniques we homogenize and try to get a such properties, and then instead of modeling each and every detail in the electrode, you take a homogeneous model in a slab. So those type of modeling can be done. This is another example of a 2D cylindrical lithium-ion cell modeling, where you have cathode, anode, and the separators, which can be seen here. And this type of modeling can be done, and you can see the here animations for lithium concentration at positive and the negative electrodes. So these are the electrolyte potential or the concentration at the anode and the cathode. And here you can see the cell voltage, which is high in the beginning and how it drops with time. So it's all for 3,500 seconds, and you can see how the cell voltage is changing with time. This is typically a modeling of a 3D pouch cell where you model electrode, negative, positive electrode separators, and you define the foils, and then you also kind of calculate the losses in aluminum foil and copper foils, and also try to find out the electrolyte current distributions. Okay, so a little bit about the pack modeling. So what we were discussing till now is how to model a cell level, or how to do a cell level simulations, where you need to choose a battery chemistry, you need to define electrode kinetics, and do the electrochemical simulations, find out the heat sources. And through that, now at the pack level, typically we want to see the heating, and then also like different ways how we can cool it. So once we have done the first part and we know the heat sources, you can use it in the pack level. And so we can model packs like this with 200 cells and do the surface. You can find out the surface temperature. And you can actually also measure at different points. You can see the cell voltages, and also you can kind of design different cooling techniques here and try to minimize the basically temperature rise in the battery pack. And along the same lines, you can also do the thermal runaway type of problems where there are various causes, short circuit, nail penetration, and so on, through which you can basically make one of the cells as failing, and then because of that, whether it's a gas venting or short circuit, the temperature of that cell can be captured as increasing, and then you can see that how that particular high temperature kind of progresses in the entire battery pack, and how you can design the cutoffs and kind of a system which avoids failing the entire battery pack. So all those things can be done at the battery pack modeling. So let me quickly tell you about like one or two use cases which are around this. So this is one of the company called Murata. So they have used and tried to simulate the dendrite formation. So this is a typical problem in lithium ion batteries, that lithium starts depositing in a dendrite form. And this is the experimental images you can see on the left hand side. Something similar they tried to simulate, and they have also found a way like how these dendrite growth can be reduced by giving a pulse current during charging. And so those results are, those designs are optimized and also validated with the experiments. This is another story by Exicom, where they have designed a BMS, where again, from the first principle, the lithium ion cells are modeled, and then the heat sources are taken and the temperature is measured. And using that temperature, they have figured out like from where this like what are the conditions for the cutoff, and also they have modeled the magnetic field response versus time, as well as the battery polarization. So different configurations were studied here. So with this, I think I would like to end my presentation here. So just to conclude, like what we have tried to cover in a very short span of time, that the role of kind of multi-physics simulation. So if you look into the deep of the cell or electrode, I mean it's highly complicated, and many physical phenomena are present together. Like electrodes can be solid or porous. There's a flow involved. There's electrochemistry happening. There's a diffusion, heating, and then maybe deformation of electrodes, failure of electrodes, and then at the pack level again, it's a heating, flow, vibrations, failures. So it's truly kind of a multi-physics problem which we are trying to model, and that is why doing simulations are anyway helpful. And if it's a multi-physics simulation which can capture all these physics, is really helpful in designing a cell or a battery pack. So with that, I'll try to end my presentation here. I think you can ask any questions if you have.
Yeah, hello.
Yes.
Yeah. So thanks a lot for presenting your topic, making the complex topic simpler for all the participants. So this forum is now open for questions. So if there is any questions, then participants can unmute themselves. They can also tell their name and the organization they are representing, and they can go ahead and ask the questions.
Hello.
Yes,
Yeah,
we can.
go ahead.
This is Pramod Gupta from Genius Innovation. I just want to understand, using your software, like whatever you are telling, the thermal analysis and the short circuit analysis,
Yes.
simulation, basically you have to, what exactly you have to input into the software so that we can get the analysis?
Okay, so basically, if you are doing a cell level chemistry, then the inputs are totally different. I have shown you some of the snapshots where you need to give the electrode kinetics and many different parameters. But now, what you are mostly interested in the pack level simulation, where you already kind of know the heat source through experiments and other data. So you can simply give such kind of heat sources, and which basically comes from the electrochemical analysis. But if you don't have that cell level model ready, you can directly give the heat sources and other inputs, and then at the pack level, basically we will do the analysis where we'll model all the cells. So we need the cell material properties and what type of fluid is outside and how the connectors are created or connected on top and bottom of the cells. So all those connections we need to specify, and of course we need to kind of model an enclosure. In that case, basically end to end you can model the heating and flow and thermal runaway type of simulation in case of say nail penetration, short circuit, and such scenario.
Okay, so your software will give the suggestions also, like once we simulate our battery pack and we
Yes.
are getting some negative reports, so will it give some kind of solutions also?
Yes, exactly. So basically, see, you can consider it this way. Suppose you have a design ready and you are going for manufacturing, right? Or testing physically. So what you can do is you can test it in the simulation virtually. So you need to mimic the entire battery pack. So there's a battery with say 16 cells, and these are the connections, these are the connectors, these are the connector materials. So everything has to be mimicking in the software. And once done, then maybe you can try. Suppose you say that one of the corner cell is failed, so maybe you can also find out that why it is failing, when it will fail. But suppose you are not interested in that, you want to see the post failure analysis. Suppose the corner cell is failed, there's a short circuit. Now you are interested in how it will propagate, the high current will propagate in other cells, or because there's a gas venting, right? How that gas, when heated gases will come out of the cell, and how it will affect the other cell's temperature. Or it may also trigger the thermal runaway or any other failure in other cells. So everything can be simulated. It depends on like how much depth you want. Those many inputs will be required. You need to kind of mimic the entire physical system in the software,
So
starting from
how
geometry and
accurate this simulation software works basically in practical way? Like you are getting some.
yeah, so yeah, I was showing you like two user stories, right, from Exicom and Murata. So basically, they got very good results. So See, there are two things. So sometimes what you want is you want to really quantify and get results, and you want to match from experiments. Sometimes you want to see an insight that, okay, like why it is happening, and qualitative feedback. So accuracy depends on like how many kind of physics you have added. For example, suppose you are doing a chemical reaction. Now, because of chemical, there's a heating. Because of heating, there is a change in material property. Typically, material property is a function of temperature. So it depends how much complexity you are involving in the model, because real life, everything is included. In real life, we don't have a choice to exclude, include. But in simulation model, you start from basic and keep adding the complex things. So depending on how much complexity you have added, or you are how close you are to the real life scenario, and how much is the accuracy in the inputs, your simulation will be accurate to that level.
Okay, understood. Okay. Thank you.
Thank you. Any other quick questions here?
Okay. Yeah. So thanks a lot, and appreciate for the valuable contribution to our event. Mr. Pawan will be us till the end of the event, and if there are any questions, we can also take it as the session ends. So thanks a lot, Mr. Pawan, for this wonderful presentation.
Sure. Thanks a lot. Just one last remark, like if you want to know more about like COMSOL or multiphysics simulation, or if you have any further queries, you can reach out to our website. You can just Google COMSOL and go to the website and read about it and contact us for any further detailed queries. Thank you, everyone. Have a nice day. Bye-bye.
Yeah, thanks a lot, sir. Thank you very much. So moving forward, we have our next presentation, and our next speaker, and he is Mr. Sai Charan Kupili, Technical Director, South and Central Asia for Jinko Solar. Before I hand over to him, a brief profile about Mr. Sai Charan. Mr. Sai Charan is a highly experienced professional with over 16 years of expertise in the renewable energy sector. His experience spans various segments of the industry, including utility scale, commercial and industrial, distributed generation, rooftop and floating applications. He has worked with reputable organizations such as Sendicop, Vedanta Group, Asset Infra, Nanobright Solar, and is currently associated with Jinko Solar. At Jinko Solar, he holds a role in managing product management and technology activities for South and Central Asia market. Academically, Mr. Sai Charan holds a postgraduate degree in electrical and electronics from JNTU. He has a diverse skill set and has been involved in various aspects of the renewable energy field, including product management, pre-sale, design, engineering, operation, and maintenance engineering, project execution, project acquisition, and business development for solar projects in the region. He has extensive knowledge of the engineering activity involved in the solar PV life cycle and has played a pivotal role in delivering custom PV design solutions with optimized levelized cost of energy for over 4.5 gigawatt of executed projects, particularly in the sensitive market like India. Mr. Sai Charan is recognized as an influential figure in the PV industry and is a key representative of Jinko in introducing latest technology trends in the PV sector to South and Central Asia. He has contributed significantly to the transformation of industry practices and has influenced stakeholders to embrace new and optimized products emerging from mono PRC and TOPCon technologies. Today, he is going to share with us insights on the technology trends of ESS, that is energy storage. Welcome, Mr. Sai Charan, for this event, and you can take it forward from here, sir.
Thank you so much, Santosh. Thanks for the introduction. Let me just share my screen. Hope you all can see my screen.
Yes, sir, you can go ahead. Yeah.
Thank you. Very good afternoon, everyone. Thanks for taking out your time to join us for this particular session. More importantly, if you just try to understand the kind of energy storage segment, which is more importantly on the name of energy security, since the entire market has been completely divided into 3 different segments. One is residential energy storage segment, and the other is C&I market, and then utility scale. So within all these particular 3 different buckets, we easily could see this particular energy security can be addressed with different kinds of storage products, which is what is coming through LFP kind of solutions or even with sodium ion. But out of these particular 2 technologies, or even with advanced lead acid kind of technologies, more importantly, lithium ferrous phosphate technology has taken a diversified shape, and the kind of market share which it has captured is entirely different. So starting with that particular preamble, just try to give you a kind of a brief introduction about the market and how the dynamics are moving on specific to this kind of energy storage solutions. If we just try to see, this particular blue is for utility scale, and we could easily see that the utility scale market has tremendously improved and increased its market size, starting from 55 gigawatt capacity. It's like 38 gigawatt capacity, gigawatt hours to 80 gigawatt hours. So a lot of improvement has happened more on the terms of utility scale. And when we try to talk about RESS segment, which is more predominantly on the fronts of 14, 20, 25%, and that has moved to 16% kind of market share figures. But it's all is happening because of the increased prices or volatility, which is what is there specific to these particular prices in the LFP technology. And since specific to RESS applications, more importantly, advanced lead acid batteries has already got majority market share within that particular segment, which is why we could see slight shift is happening within this particular segment of RESS, where down the line within a span of 8 quarters, we easily could see that this particular value of 16 gigawatt hour capacity may move down to 17 gigawatt hours to 20 gigawatt hours within span of 2 to 3 years kind of timeline. And similarly for 2024, if you just try to see, since because of these particular RTC tenders, which is what is coming through SECI or NTPC or NHPC or any other public PSUs, where in which we easily could see that round the clock tenders are making much more pivotal role, where we easily could see that that particular capacity or the market share is going to touch beyond 80%. And that's where we easily could see that 110 gigawatt hours is a kind of requirement, which is what is expected globally. And if we just try to look region wise, more importantly, China has got the majority market share within this particular thing in all different segments, whether that can be with the utility scale or C&I market or residential segment. So out of all these particular things, we easily could see that specific to our market, where South Asia region is falling in, it just started picking up. So probably within span of 8 quarters to 12 quarters kind of timeline, we could see that by the end of 2025 or mid of 2025, we could see certain installations which will be touching around like close to 2 to 3 gigawatt hours. That's what is expected as per the market numbers has been considered. Out of all this particular energy storage segment, if we just try to see whether that can be with any of these particular 3 different segments, whether that can be with utility or C&I or RESS, the most important aspect which generally comes in is specifically starting with the cell manufacturing, which is more predominantly on the battery side. And these particular batteries, if we just try to see, 3.2 volts, 100 Ah is what is being utilized, or 80 Ah is what is being utilized for RESS kind of markets. And specific to C&I markets, it's just standing at 100 ampere hour or even close to 280 Ah. And looking at utility scale, they are standing in between 280 Ah to 300 Ah, or even 320 Ah is also expected specific to this particular cell capacities, which will be stacked up in a module, and then module to pack to rack. And then that's how it's going to be considered within the entire container kind of thing. So altogether, if we just try to understand this particular scenario, the cycle, what exactly is happening within this particular energy storage solution is that battery manufacturing is one particular segment, which is cell manufacturing. And then BMS manufacturing is completely getting included along with the integration segment of all these particular aspects. And PCS is definitely a kind of different inverter kind of segment, where already mature players are there within this particular PCS manufacturing, where players who already have got technology innovations in the segment of in the segment of these particular power conductors, definitely on the fronts of power converters, they have that particular edge on this particular segment of PCS, which is why not many players are trying to concentrate on PCS manufacturing. But yes, when it comes to cell plus BMS, it's completely going to be a kind of a new area and new area of segment where in which people easily can strive to get that particular pouch, where in which this particular cell plus BMS is a kind of new avenue within the entire energy security kind of solution. Apart from this, we easily could see that EMS is a kind of software segment which is getting integrated with BMS and PCS to understand the pneumatics of these particular solutions, and then integrating all these particular aspects with the cloud solution is completely going to make a kind of comprehensive solution rather than a product. So altogether, if we just try to see for these kind of ESS solutions, whether that can be with utility scale or C&I or DG kind of segments, altogether battery plus PCS plus EMS plus integration. All these particular 4 different segments are going to create a kind of solution. So looking at Jinko, if we just ask us what exactly is the capacities that we hold on this particular segment, because on the technology side, if we just try to see, everyone are trying to bet now more on lithium. Earlier, it was only with lithium ion or lithium titanium kind of compositions, but now it has been moved to solid state electrolyte, where in which it's making much more sense on the name of energy density, which is why we could see LFPE technology, which is lithium ferrous phosphate, is having much more predominant benefits on the aspects of levelized cost of storage, which is what is required at the end of the day for any end user. That's why even we started our composite materialization or trying to provide these particular solutions starting with LFPE only. For this particular year, we have target of crossing beyond 4 gigawatt-hour kind of solution, even with the integrated mechanism of system integration. But yes, starting from next year, starting from Q1 of 2024, we'll be manufacturing our own cell from our own factories itself. So that way you usually could see that 12 gigawatt hour is going to be our cell manufacturing, with 16 gigawatt hour as a kind of complete integrated capacity of system. And similarly, by 2025, we have plan of touching the same values up to 28 gigawatt hours with 24 gigawatt hours of cell manufacturing. Altogether, because people have got a kind of a perception specific to or a kind of comparison between lithium ferrous phosphate kind of technology and sodium ion kind of technology. But if we just try to understand the kind of number of cycles specific to depth of discharge, definitely the existing current cell capacity is now standing at 3.2 volts, 280 Ah as a kind of standard conventional product, which is what is available. But now this is going to touch around like 304 to 306 ampere hour with the same 3.2 volts. But it even can touch around like 10,000 cycles as a kind of number of cycles or the life of these particular batteries. So gradually we could see that by the end of 2024, we could see this particular long cycle life is also expected, where the life of these particular cycles with depth of discharge of 80% can even touch around like 12,000 to 15,000 cycles. And in regular phenomena, we are now seeing it as a kind of 8,000 to 10,000 with a minimum depth of discharge of 80% or 70-75% kind of thing. But yes, by increasing this particular depth of discharge to 90%, we can we'll have the other side of these particular technology, you can say like disadvantages or a kind of advantages, where in which increasing the depth of discharge definitely will reduce the number of life cycles. So that way it is highly flexible, and even it can touch even up to 100% depth of discharge. Probably it will be touching it around like 99% or 98% kind of thing, where in which number of cycles can be reduced up to 6,000 cycles to 7,000 cycles. And going forward, the same capacities, what we expect within this particular LFPE technology is that by 2025, the same 3.2 volts energy density is going to touch around like 450 ampere hour or beyond that. Close to 480 Ah is also expected. So that even can cross beyond long life cycles of beyond 15,000 cycles to 17,000 cycles. And if the same thing is being considered with sodium ion technology, which is still in nascent stage, which is just standing in between 4,000 to 7,000 cycles. And to reach this particular value of 7,000 cycles, its expected timeline is during 2025. And by that time, LFPE itself is going to stand at around like 15,000 or more than 15,000 cycles. And the kind of industrialization, what we are trying to do with our own BMS, and not just limiting ourselves only to provide these particular integrated solution or just manufacturing only the cell, but yes, even we have plans of developing this particular BMS along with our existing cell itself. So that's how we easily could see that a kind of cloud platform has already been created with the OPS cloud, where in which the tickets can be raised on 24/7 kind of basis on any kind of maintenance activity specific to the solution, whatever we are trying to provide. So that way it's going to have a kind of complete comprehensive solution mechanism rather than just giving it as a kind of product. So by 2024 Q3, you easily can expect that this particular cloud is even getting extended to the other segments, even to RESS kind of segments also we are trying to extend this thing, which means any of our clients, whomsoever is holding our product, they can raise any kind of ticket 24/7 and it's going to be resolved within 24 hours kind of time. So that's how this particular BMS is going to communicate with our OPS cloud. And also EMS is also, it's a kind of software mechanism where as of now we are outsourcing the same thing, but slowly and gradually we want to integrate that particular EMS part also within our existing solution going forward. And on the fronts of energy storage products, as I was trying to explain you right from the beginning, that we try to cater these particular different products in 3 different buckets. One is specific for the residential market, C&I market, more importantly for the commercial and industrial segment, where all-in-one kind of solutions are being expected. And for the utility scale, which is what is required for RTC kind of tenders, where up to 3.44 megawatt hours is the kind of single container solution can be provided with these kind of utility scale kind of solutions. And which is why we try to call these particular products in 3 different names. Specific to residential, we call this as SunTank. And for C&I, we call that as SunGiga. And for utility scale, we call that as SunTerra kind of solution. So this is how we try to mention specific to SunTank, which is what is there for residential segment. It generally comes in both low voltage application and high voltage application. Starting with 1 kilowatt hour kind of requirement, we even can move this particular application up to 20 kilowatt hours. So it completely depends on stacking these particular levels. It's like 5 kilowatt hour is a kind of single stack. It can be stacked up to 4 stacks. 4 parallel stacking is possible within this kind of RESS solution. And this is a kind of predominant solution which is being used widely in Australian market. And yes, probably for our market also, we easily can consider this because it's completely falling within the limitations of local grid code compliance requirements of Indian markets as well. And on the fronts of same RESS solution, we are trying to provide in both low voltage application and high voltage application, which is more related to single phase and 3 phase kind of thing. So yes, for all kinds of residential application, probably we can stack these particular things up to 20 kilowatt hour, even up to 50 kilowatt hour also, we can try and get the solutions within SunTank kind of solutions itself. Anything going beyond 50 kilowatt hours, probably that would call for C&I kind of segment applications where our SunGiga solution generally comes in place, which will have the similar kind of mechanism as what you usually could see here, where you could see that this is a kind of single containerized kind of solution where it will have 344 kilowatt hours as a kind of single cabinet kind of solution, we can say, where this particular single cabinet is only DC to DC kind of application. If someone is asking for all-in-one kind of solution, which means the same cabinet will comprise the battery bank, the PCS, and the BMS. And if that is the case, this all-in-one solution comes with 100 kilowatt as a kind of continuous AC output from that particular cabinet solution, which even can go up to 215 kilowatt hours as a kind of output. So altogether, we just need to understand whether you need AC coupled system or a DC coupled system, or you need all-in-one kind of solution, or you want to integrate this particular PCS separately from the existing DC cabinet solution. So that way, we easily can integrate these particular mechanisms. It's more importantly, these particular packs has to be integrated within that particular rack and see what exactly is the system capacity or system demand as per the demand of that particular load. Accordingly, we easily can design these kind of all-in-one solutions. And more importantly, it again has to come in compliance with the grid code compliance requirements. If it is a kind of grid interactive solution for different peak shaving kind of applications, or depending on the application, even if it is a kind of microgrid kind of application, probably you can try and go for this as a kind of standalone kind of solution, where these particular solutions are highly optimized, which is the reason why we easily could see that all ESS solutions always try to be a kind of customized solutions as per the need and requirement of that particular solution requirements. And this is the typical solution, how exactly it looks like specific to C&I kind of market, where this is a kind of simple cabinet solution, where this cabinet generally comprises of 8 packs if it is a kind of DC-DC solution. But if you're trying to go with all-in-one kind of solution where you will get 215 kilowatt hours within 5 packs itself, which means these particular 5 packs will be there, and then in the below section, PCS is going to be integrated. So this is a kind of simple integrated cabinet where it is having 100 kilowatt as an output and 215 kilowatt hours as an output on the energy part. So if you are trying to go with only as DC-DC kind of solution, instead of 215 kilowatt hours, it's going to be provided with 344 kilowatt hours as a kind of output, as a kind of DC cabinet solution. So it completely, it can be optimized even up to 100 kilowatt or 100 kilowatt hours or 100 kilowatt of 150 kilowatt hours. It completely depends on your need and requirement. So this is what
I ask one question. What exactly you mean, the DC to DC system? India, only the loads are mainly ACs, no? I do not.
Yeah, it's completely AC. So you can see this particular image where let me just try to show you. Yeah, so this is a kind of cabinet. So within this particular cabinet, you easily could see that this particular segment, here we have 5. If these particular 2 segments, this is an all-in-one solution. If this is not an all-in-one solution, it will have only battery bank. So which means here we will have 3 more racks where instead of 215 kilowatt hours, the capacity becomes 344 kilowatt hours. Yes, India has got only AC loads. For that, what we need to do is, if it is a kind of DC coupled system, probably you can directly connect at the input of your DC or your charge controller segment itself or the battery management system. But if you have a kind of AC requirement, so then it can be a kind of AC coupled system. For that, what you can do is that you can connect the output of this particular PCS. So this is something kind of all-in-one solution where you can connect directly as a kind of AC output. Even DC cabinets also can be connected to your AC output, provided the PCS segment has to be connected separately. So it completely depends on you. Like, assume that if your solar PV power plant is coming with DC, and if you want to connect that particular DC with your charge controller segment to charge your DC cabinet solutions on a kind of DC-DC application kind of thing, and then use that as a kind of backup for your backup load options, probably you can utilize that thing. But the only thing is that specific to DC-DC kind of configured solutions or DC coupled configured solutions, you will have better round trip efficiency, and it is limited only to specific capacity. And if you try to go for AC coupled systems, definitely you will have reduced round trip efficiency of the entire solution. But again, it's like, since we have certain regulations on the DC coupled systems, which is why people cannot go beyond 5 stacks within this particular DC coupled systems. Otherwise, even we can connect 5 gigawatt hours or 5 megawatt hours kind of solution on DC coupled solutions. But actually, it is not going to make safety wise, it's not going to have the kind of compliance requirements cannot be fulfilled for higher capacity rating systems, which is why people always tend to go with these kind of DC coupled systems or DC-DC systems, more specifically as a kind of input from solar PV power plants to these particular DC cabinet solutions, where PCS is not required. But if PCS is completely coming in place, definitely you'll go for that as a kind of AC coupled system. So these are the typical parameters, which is what is coming from a kind of DC cabinet, where you can see that this particular solution is providing close to around like 215 kilowatt hours. Instead of 215, this even can be made 344 without this particular PCS. If PCS is there, this becomes 100 kilowatt as a kind of AC output. And this is the area where we can see that particular BMS part, and then air filters are going to be there. And this is completely coming as a kind of solution with a liquid air cooling kind of mechanism, which is why we could see that the auxiliary consumption of this particular solution is far less when compared with forced air cooling systems, which is why we could see the levelized cost of storage of these particular products is much lesser when compared with forced air cooling systems. And the most important aspect, what we try to do, how we are trying to increase our energy density within this particular segment, within this particular pack, is that the kind of intelligent design, what we are trying to do is that the heat transfer mechanism is completely getting observed and monitored in 5 different zones, which is the reason why you will have less temperature, less operating temperature, where thermal management is having better functionalities when compared with conventional pack design. which is the reason why you could see that the auxiliary consumption of these particular solutions is very less, and it operates in multi-working modes with this particular liquid cooling unit, which is why you can see that all kinds of environments or gas or fire suppression or any other aspects are getting completely controlled and covered with these kind of solutions, and which is the reason why our auxiliary consumption is less. That in fact is going to reduce your LCOS, which is the levelized cost of storage. And we have our intelligent storage system specific to SunGiga Cloud, where every component or every metric of this particular component is getting monitored within the cloud, which is the reason why cell level temperature monitoring is happening. And as and when there exists any kind of abnormality, it's completely going to hit within the cloud, and that will be resolved immediately from the cloud itself. If it is not resolved through cloud, then our person generally tries to visit the site and try to address that particular issue as per the need and requirement. Apart from this, even for C&I kind of applications also, we are trying to provide the similar kind of applications with SunGiga. And for this is for SunGiga, and similarly for SunTerra applications, if you just try to see, the same kind of mechanism is going to fall in place, but instead of 250 kilowatt hours, this entire container is 20 feet container, which is going to come as a kind of 3.44 megawatt hours with 280 Ah kind of battery pack kind of capacity. So which is why we could see that this entire container, which is 20 feet container, is coming as a 3.44 megawatt hours. And going forward, we are trying to increase this particular capacity of this particular container to 3.76 megawatt hours going forward. And starting from 2024 Q2 onwards, probably this is going to touch at around like 320 Ah, 3.2 volt cell is the kind of configuration which we have planned in for. So that way we could see that these particular 3.44 gigawatt hour application is going to completely touch for the utility scale segment, and even for C&I market also this can be utilized. So this is what our SunTerra solution looks like, which is completely having compliance requirements as per UL and IEC, where in which we easily could see that this is a 20 feet container where it can operate in 0.5 C or 0.25 with 5 megawatt hour as a kind of SunTerra kind of solution, which is what is expected for 2024. And as of now, it is now standing at 3.44. Even can do this particular value at 3.72 megawatt hour, which is what is there for this particular Q4 of 2023 and Q1 starting of 2024. And starting from Q2 half, mid of Q2 onwards, till Q1 of 2025, you easily could see that 5 megawatt hour is a kind of SunTerra solution, which is coming with a kind of single 20 feet container. And these are certain certifications, which is what is there specific to this particular product, and it is completely adaptable to all kinds of environmental zones, which is why it is getting completely monitored in 5 different temperature zones, and it's completely CCS certified, pre-populated, which is completely having a kind of transportation certification. Altogether, it's a kind of SunTerra solution is a kind of complete DC solution kind of thing, which means it's only a kind of battery bank kind of thing, battery container. And yes, this can be connected to PCS and then to your EMS, because this particular battery container is completely comprising of a BMS also at this particular section, which is completely cooled with liquid cooling mechanism. Each and every cell is being monitored on the temperature parameter, and it's completely integrated with separate PCS. So separate PCS is going to be there, and that particular interconnection is going to happen with this particular SunTerra solutions on the DC side. And then that particular PCS can be connected to your MV transformer and then your MV panel to your main control room, and then connecting to EMS part within the same segment can provide you better values of entire comprehensive solution. So that way we easily could see that this particular solution is completely operating within the zone of minus 20 degree to 50 degree C. Yes, there will be some kind of duration, which is what is going to happen after 50 degree C. But most of the time, because it's being monitored through this particular, not through forced air cooling, it's completely getting done with liquid air cooling. Operational temperature is always trying to maintain in between minus 20 or 20 degree to 50 degree or 40-45 degree, so that at majority of the time, specific to Indian climate zones also, it's going to have a better operational efficiency when compared with normal conventional containerized kind of solutions. So altogether, it's in totality, if you just try to see the kind of effective cooling mechanism, which is what is happening through liquid air cooling, is one major parameter, which is a kind of design innovation which has happened with reduced auxiliary consumption, which is why it is more efficient. with high energy density, which is what is happening. Instead of going with 280 Ah kind of batteries or 100 Ah kind of batteries, it's now going to move towards 300 to 306 for this particular quarter. And it's completely reliable and safe because it's getting monitored on cell level itself on the temperature. And 5 temperature zones are being considered for the same thing, which is why it's more reliable. And on the intelligent O&M wise, since it's getting connected to the cloud on immediate basis, where response time is going to be going to be less than 3 seconds kind of time, which is why any abnormality observed in the system can easily be popped out in the cloud, and that easily can be addressed from our direct HQ cloud team itself. So this is the innovative design what we have done. So this particular design part, since we have gone with a kind of innovative design on the heat sink, heat plate, just because of that, we have reduced the auxiliary consumption of this particular panel to 20%. And that's the reason why we could see that it increases the life by 10% more. And which is the reason why we could see increased number of life cycles are going to be there with this kind of Sunterra kind of products, which is coming with these particular racks. So this is how we are trying to manage. And more importantly, it's more efficient because the kind of automatic dropout or automatic rejoin is completely happening because of active balancing, which is what is happening from cell to cell, so that there won't be any kind of mismatch from masters to slave kind of configuration. And this predominantly will increase the system efficiency by 1% more. So altogether, it's a kind of smart management. It easily can be commissioned with efficient in a highly efficient manner. And real-time monitoring is completely happening through cloud. With this, I just try to show these are certain case studies, which is there's a kind of 20 megawatt hour solution, which is exactly beside our factory. And even these particular solutions are being used in, these are RESS kind of solution, and this is Sunterra kind of solution, and this is a Sun Giga solution. This is also Sunterra kind of solution. With this, I end the presentation and would like to answer any of your queries.
Yeah, thanks a lot, Sai Charan, for this wonderful presentation, giving us key insights on the technology development and Jinko Solar's product roadmap that is there. So this forum is open for questions. If there are any questions, you can ask. You can unmute yourself. Please mention your name and the organization that you are
representing. Can I put up a question?
Yes, sir. Please.
Mr. Sai, thanks for that wonderful presentation on the development of ESS. Now, I'm only out of curiosity, one question where you mentioned your Sunterra energy storage 20-foot container, where currently you have been able to stuff 3.44 megawatt hour as energy in 20. Currently, whatever, and obviously you mentioned LFP chemistry, so it has to be some kind of prismatic. It may be choice 100 to 280, which is more prevalent and readily available across.
Absolutely.
Now you mentioned going forward, you are showing a 5.01 megawatt hour in the same container, which Jinko is working with. So now, out of curiosity, my question is it because of a high volume density cell choice, or you are going to optimize so much other thing, balance of the system other than the cell itself? Because today, the cell of energy cell, all these ESS are supposed to work for 10 plus years minimum. And everybody talk about 6,000 to 10,000 cycle life of this kind of cells. It is very amazing to see, 3.44 to 5.01, it is 45% jump. And 45% jump is, if I see only for the cell chemistry, today any LFP chemistry energy cell somewhere around 160 watt hour per kg on the energy density. And if you talk about purely because of that, then it will go up to 217 to 218 to achieve this 5.01 in the given same. This other one maybe volume density. So
absolutely.
What exactly, because it's a big colossal jump from 3.44 to 5.01. Is it because of some chemistry advancement, or is it because of some other design aspect within that, which is going to save and stuff and, release some space which will be occupied by more cells? So what exactly Jinko is working on?
Yeah, absolutely. You rightly said, if some kind of capacity is being increased, it's just that increasing the cell volume density, definitely it can go even up to 4.2 megawatt hours kind of solution with the same container. So altogether, what we are trying to work out on that is this particular thing specific to 5.4 megawatt hour, 5.02 megawatt hour is that it's going to be a combination of cell volume density and also reduction in the spacing within this particular 20 feet container, which means the spacing now what has been considered is close to around like 1.2 meters. This probably even can work at 0.8 meter spacing also of these particular 4 blocks.
Okay.
When these particular 4 blocks are being met at 0.8 meter, 0.6 meter to 0.8 meter, where the density of the volumetric density within the container is also going to be reduced, and that in fact will increase your energy density as well. So that way we are trying to increase the cell volume density a bit to meet this particular value of 5.5 megawatt hour kind of solution within the single 20 feet container. But yes, on the other side, we are trying to optimize the other fronts, which is more specific, the spacing of these particular packs, which is what is going to happen.
Yeah. Thank you. Thank you, Sai, for addressing that. Thank you.
Yeah, thank you, sir.
So thanks a lot once again, Mr. Sai Charan, for this wonderful presentation. And he's going to be with us for the rest of the event. So if there are any questions, probably we can take afterwards also. So moving on with our event, we have our next speaker, that is Mr. Akshay Kumar, and he is lead e-mobility at India Energy Storage Alliance. Before I hand over to him, a brief introduction about to Akshay Kumar. Akshay holds a master's degree in automotive engineering from Birmingham City University, United Kingdom. Complemented by his earlier education, including his schooling and a bachelor's degree in mechanical engineering obtained in Delhi, India. His education journey has fostered a deep passion for powertrain and control systems with a strong inclination towards engaging in research and development endeavors. With experience as both a team leader and a collaborative team member, Akshay has consistently demonstrated efficiency in successfully delivering a variety of projects and activities. His professional journey encompasses engagements in diverse organizations where he has also actively contributed to various research publications. He is going to shed light on, he is going to share his views on the EV market, and he is also going to share key highlights about the EV policy that is there. So a warm welcome to Akshay Kumar, and you can take it over from here.
Thank you. Thank you so much, and good afternoon to everyone. Shall I share my screen?
Yeah, you can go ahead. Yeah.
Okay. Okay, is everybody able to see my screen?
Yeah. Go ahead.
Okay, thank you. So thank you for giving me the opportunity to present at this event, and I am here to discuss the brief overview of EV and EV battery market. With that, I'll be also discussing on touching base on a few of the key EV policies launched by the central government to accelerate the EV adoption in India. So let's just first deep dive into the EV sales of 2022. So this was the year when the EV sales touched the 1.2 million ballpark, or crossed the 1 million barrier that was it. And we saw that 60% of the market share was taken by two-wheeler, 39 by three-wheeler, and the rest was between four-wheeler and electric buses. If we include 2023 sales, then till date we have reached around 2.1 million. And but what we are seeing in 2023 is we have seen a major dip in two-wheeler sales from the month of June to August. Okay, fine. We'll discuss this in my later on slides, but now let's move on to the battery demand of 2022. So battery demand for to satisfy all these vehicles, it came out to be 10.5 gigawatt hour, out of which 62% was for two-wheeler, 20% for three-wheeler, 14 for four, and rest 4% was for electric buses to support and run them. Now, if we talk about leading chemistries, what are the leading chemistries in across the segment? So either it be 2, 3, or 4. So I have what we saw in terms of two-wheeler, high-speed two-wheeler. We saw that NMC is what is dominating as of now, and for electric three-wheeler high-speed, I'm talking about LFP is the dominant. Similarly, for four-wheeler, LFP is there for passenger vehicle, and NMC was 40% dominant for electric buses. So now let's talk about the focus of these EV sales and also the EV battery demand. So from 2022 to 2030, we are estimating around 53 million unit vehicle would be sold, and 53 million vehicle would be added on road, and out of which again the two-wheeler market would be leading, and it would be dominant with 79% of the market share. And to run all these vehicles, we would need a forecasted number of total 596 gigawatt hour battery demand till 2030. And this is just business as usual. I'm not even talking about when the FAME 3 comes and the demand could even go up, and that then the battery demand would also increase. So to support all these demand and everything, we need a robust policy, and we'll be talking about some of the key policies that are established by our government. So let's talk about FAME policy. FAME is one of those key elemental policies which initiated and took the EV mission to a next level. So in 2015, the FAME scheme was launched for 2 years, just to increase adoption and manufacturing of electric and hybrid vehicle, with a budget outlay of 795 crore. So this was, let's just call we called it a FAME 1 scheme. So it had a budget of 795 crore, and it was supposed to go on till 2017, right? But it got extended for 2 more years, and it also extended the budget to 895 crore. So out of which 359 crore was dedicated for 2.8 for launching 2.8 hybrid and electric vehicle on road, and 280 crore went to deployment of 425 electric and hybrid buses. And the remaining 43 crore was for deployment of 500 charging stations under this scheme. And when we talk about FAME 1, it was a raging success. And frankly, so government thought we should be launching FAME 2. And in April 2019, FAME 2 was launched, and with a budget outlay of 10,000 crore, with a key objective to electrify the public transportation and also establish more charging infrastructure. So let's look at what happened in FAME 2 now. Now in FAME 2, there are 3 main categories. So to create the demand, budget of 8,595 crore was budgeted to incentivize 10 lakh two-wheelers, 5 lakh three-wheelers, 55,000 four-wheelers, 7,090 electric buses. So this was the intent of the FAME 2. And to establish more charging infrastructure, 10,000 crore was 1,000 crore was budgeted. And the remaining 38 crore was actually went towards capacity building, education, and all those kind of things. So if we see the charging infrastructure side of the FAME 2, so around 4,453 charging stations were sanctioned, out of which 2,877 charging stations went into 68 cities across 25 states, and 1,576 charging stations were sanctioned for 9 express highways and 16 highways. So out of which 452 stations were installed until 7 December 2021. And in 2021 itself, 1.4 million, 1.4 lakh vehicle were incentivized, out of which 1.19 lakh were only two-wheelers. So why did we see a huge jump in two-wheelers in this 2021 year? So this was mainly because of the demand incentive, which was increased, which was earlier set to 10,000 per kilowatt hour, and now it in June 2021, DHI increased it to 15,000, which 15,000 per kilowatt hour, and a cap of 40% of the cost of vehicle. So now this poured the gasoline on a fire, and it acted as a multiplier for the two-wheeler industry, and we had seen tremendous amount of sales in the year of 2021 and 22. So moving on, let's see what happened 2022 to 23, that financial year. What was the main outlay of it? So in this year, we saw around 6.63 lakh two-wheeler were incentivized, 70,000 three-wheeler, 5,375 four-wheeler, 3,738 electric buses received incentive. So all these vehicles received a collective incentive of 3,300 crore under the FAME scheme, which is a huge amount, isn't it? So, and also the charging infrastructure, remember where I discussed that there were 4,453 charging stations to be deployed across cities, express highway and highways. So out of which 1,014 charging stations have already been sanctioned and installed by DHI under the FAME 2 scheme. And electric buses, if we talk about them, the DHI sanctioned electric buses, which were 7,210, out of which 2,435 electric buses are already on road. So, but as I was earlier talking about that in 2022, this 2023, the sales dipped. And what was the reason for that? In 23 June, again, DHI reduced the incentive for two-wheelers from 15,000 again to 10,000 per kilowatt hour, and capping at 15% cost of the vehicle, which created a surge, and the sales for June, July, and August were actually flatlined, and it was quite low. We recorded a huge sale in the month of May, and it was one of the highest sales till date. But we are seeing the industry grow again, and this is mainly because now that the demand and incentive have been reduced to 10,000, so the entire model and the pricing of the vehicle has to be created accordingly, and the entire business model has to be recreated. That is why the sales were too low. Okay, so moving on. Now we'll look at what is product link incentive or PLI for auto and auto components in India. So in this scheme, it was launched to accelerate manufacturing of auto components for advanced automotive products. This was the intent of the scheme, and with a budget outlay of 25,938 crore. So that was the budget allocated for this program. And under this program, 115 companies applied and only 85 got selected, approved under the PLI scheme, and 18 were under the Champion OEM scheme, and 67 were under the Component Champion Incentive Scheme. So in this scheme, in this policy, 50% localization was mandated, and it is still there. And incentive are given from 13 to 18% based on sales value. This was the entire overview of the auto component scheme. Coming up to the PLI for advanced cell chemistry battery energy battery storage scheme. So this was intended to achieve the manufacturing capability of 50 gigawatt-hour of ACC, which is advanced cell chemistry, and 5 gigawatt-hour of niche ACC. So this had a budget outlay again for 18,100 crore, and 10 companies mainly bidded under this, and out of which 4 companies actually got selected, and Hyundai, so which were Ola Electric, Rajesh, and Reliance, Rajesh Exports, and Reliance Industry Limited. And also there was another company. The 4th company was Hyundai Global Motors. So, but Hyundai Global Motor pulled their bid out, and now the shortlisted companies are Ola, Rajesh Exports, and Reliance Industry Limited, with a total capacity allocated of 30 gigawatt-hour, and out of which 20 is allocated to Ola Electric Mobility, and Rajesh Export Limited has 5 gigawatt-hour, and another 5 gigawatt-hour has been allocated to Reliance New Energy Storage Solar Limited. Sorry. Okay. So now what would happen to the remaining 20 gigawatt-hour? 20 gigawatt-hour was actually government decided to split it into 5 each, and the bids have been opened again to auction it off. With that, now let's look at some of the policies which were launched by our Prime Minister, and which were released in parallel to these champion policies. So one of them was PM Electric Bus Seva Scheme. So our Prime Minister Shri Narendra Modi had approved a scheme called PM Bus Seva, which was to operate 10,000 electric buses in a PPP model, which is private public partnership model, and which had a budget of 57,613 crore, out of which 20,000 was was to be provided by the central government, and the rest by the private partners. And this scheme will support the buses for next 10 years, and will also generate around 45,000 to 55,000 direct jobs. And this scheme was divided into 2 parts, intercity and intracity. Intercity buses would cover around 167 cities, and intracity would cover 181 cities. So this was the intent of the scheme. Again, our Prime Minister did some modification in the PLI scheme for semiconductors. So let's look at what were the modification over here. So for the fiscal support of 50% of the cost, project cost on setting of the semiconductor fabrication. So for semiconductor fabrication, the project cost of 50% of the fiscal support will be provided by the government. Similarly, another 50% support would be provided for setting up of display fabrication, and again 50% of capital expenditure for setting up of compound semiconductor and silicon photonics, sensor fabrication, and semiconductor AMTP and OSAT. So these are the facilities to be established in India. If they are established, 50% of the capital would be supported by the government. So this was few of the policy support to accelerate adoption of EVs in India, and these are the key initiatives by government. So this is where I end my presentation, and I would love for everyone to ask any questions they have. Thank you.
Thank you, Akshay Kumar, for this wonderful presentation, touching upon the overview of the EV market and the key policy highlights that you have given to the participants. So the forum is now open for any questions that you may ask to Akshay. And you can
Akshay,
unmute.
Akshay, this is Pramod Gupta from Genus Innovation.
Yes, sir. Please tell me.
Yeah, two things basically I would like to know. One is we've shown the data that in 2022 to 23, only 70,000 e-rickshaws are registered in the FAME 2.
Yes.
But on one website is around 5 lakhs, 5 lakhs to three-wheeler and 7 lakhs two-wheeler were registered in FAME 2. I was a little bit confused about your data.
1 second, let me just see. Yeah, you were talking about?
Three-wheeler
Right.
rickshaws under
Uh-huh.
FAME. You told about 70,000 only registered in 2022 to 2023. It is correct
Yeah.
in one of your slides.
Right.
So, but one data says around 5 lakhs E3 rickshaws were sold in 2022-23.
Okay, so there might be some kind of a mistake in my slide itself. I'm noticing it right now.
Okay.
So yeah. So
Okay, that is one thing. Second
Yes,
thing
yeah,
is you talk about the PLI scheme. So this extra 20 gigawatt of advanced AICC. It decided or it is just it is a discussion whom they are planning to give the license to manufacturing the cells.
They have already decided to break it off in 5 gigawatt hour each, and then auction it off. So
Okay, it is not been auctioned as of now, huh?
No, not yet.
Okay, not yet. Okay, thank you. Can you share this slide to every? It is in pub. Can we get this your presentation? Is possible?
I'll be sharing it to Mr. Santosh, and
Okay,
maybe
from there we can get it, huh?
Yes.
Okay, sure. Thanks. Okay.
Thank you.
Yeah, thanks a lot, Akshay, and for the information of all the participants. As soon as we get the presentation, I will definitely put it in the WhatsApp group that is there for all of them to access. So once again, thanks a lot for this wonderful presentation.
Thank you.
So yeah,
I have one question, Santosh, if you can put across.
Yeah, go ahead. Yeah.
See, repeatedly I've seen this criteria for availing the multiplier on the matrix of incentive under the PLI for ACC.
Right.
Fundamentally on the electrochemistry, which we have tried to understand across the globe, which is already matured, available, and way forward, everybody has their roadmap for improving and innovating on those chemistry. It's very surprising. It's my humble request through ISA to be submitted to the MHI whenever they are formulating this kind of metrics for incentivizing.
Right.
It is fundamentally against and contradiction to the basic fundamentals of the chemistry. You cannot achieve a higher energy density, which everybody is working towards, complemented with the same 10,000 of cycle life.
Right.
Energy cells fundamentally, just now we had a presentation from Jinko.
Right.
Any energy cells, so-called for energy storage, cannot be at the same energy density for the same variant when it's applied for mobility.
Right, right.
100 Ah mobility cell,
Hmm.
you can achieve with 200 watt hour in LFP. You can have the roadmap and innovation on the materials to achieve 200 watt hour for mobility, because you want higher energy density in mobility. But you don't expect 10,000 cycle life for mobility. But energy storage, the projects which already are in pipeline and already lot of tenders, UPCCL and other SECI projects, if you see, they talk about 12 years O&M and 12 years of warranty and 12 years of OPEX model along with the CAPEX. So definitely one has to go for high energy cells, which are very low energy density compared to their same model for mobility. So
Right.
10,000 cycle, 20,000 cycles, 6,000 cycle is always at the trade-off of energy density. But to my surprise, whenever I've seen the multipliers given, X factor, wherever you qualify on the matrix of energy density with this thing, they only show you, like I would say, a sweetened, a virtual thing, a hypothetical thing, which is never going to happen. Worldwide, wherever the electrochemistry, especially today talking about lithium or any other, sodium ion is highly spoken of, LFMP is highly spoken of. You see their basic fundamental specification. Sodium with 3 volt and 3 volt voltage regime. Obviously, with the comparative LFP, it will be on the lower side for the same age. So it will be a very low energy density. And then we are talking about any energy cell. How we are going to see? Because it says you'll get 1 point something to the ratio of, again, 1 point something multiplier if you achieve that 10,000 cell plus 240 odd something watt hour or 400 watt hour per kg. Both cannot match. So this is the basic fundamental thing. As an advisory member of MHI, what I assume ISA is one of the esteemed member.
Yes. Yes.
These are the basic flaws in the whole thing. And again, it's been repeated, whether it's a fall off of the 20 gigawatt hour of Hyundai coming again. But things have never changed.
Yes.
So are we promoting now the demand side you have shown 596 gigawatt hour?
Right.
A roadmap of next 7 years. We are already on 23 and 2030 are showing a projected demand of 596 spread across 58 million units of only electric mobility.
Yeah, that's
They're
true.
forgetting still the energy storage. Correct.
True.
So
Yes.
where the government policy should be conducive to enable the whole participants and the investor prospecting or entrepreneurs or startup companies who want to venture into this space and travel as a contributory member for green energy in India, for establishing whether in the whole ecosystem as a manufacturer, as a component, as a charger or whatever. I think this policy should be directed, facilitating rather than, hindering the whole thing approach. What my personal view, deeply studying this, we were one of the participants in the earlier PLI. We have deeply studied this, but we realized that it's never achievable. Never achievable at the highest metrics.
Yeah. So, so what we can do is we can discuss this one-on-one, and maybe we can also have a meeting with DHI and take this forward, right?
Correct. Because even one interesting figure which you show the sale drop in the month of June.
Right.
It is attributed to multiple factors. Before June, or if you see 21-22, when the highest number of electric two-wheeler, the top three members of the Vahan portal was someone else, which are never there in the next post. That what's the reason, one has to understand.
No,
all of them, where those companies vanished. Are other people going to meet similar kind of fate with this kind of hard-line policies from the government? One side, they have taken the pride in declaring 3,000 crores has been disbursed. Another side, all these people who are no more in the list on the top 10 who are there. I don't want to put the names, but everybody is aware.
Yeah, absolutely.
Other side, they
understand.
are imposed with heavy penalties, and it is coming back. So, what is the actual disbursement and how this industry is going to evolve with this kind of scare and fear, system built across? People who are going to put heavy money. It's a heavy capex industry.
Right, absolutely.
As far as India is concerned. So I think their government should need a very practical. First of all, disbursement happen, and second time you are telling it happened in a wrong way. I don't know. So
Right.
that's something we either some very concrete and stringent measures before, so that you see, it's not only the one party which suffer, the whole thing in that whole chain have suffering. Their vendors will suffer. And once the whole ecosystem start crashing down because of this harsh policy, we can go and see what's happened to the fate of the vendors who have been supporting these 4 or 5 people who are no more there. They are also in the bad shape. So it's a very deterring factors which need to be with very realistic approach and soft hand. We should move into this market if we want to see that practically happening. These numbers, when we sit at 2030 and people share this thing, we can see that today demand already India is somewhere around 600 gigawatt hour.
Right.
That's my submission. It not to be taken other way.
No, absolutely. Maybe we can take this further, and we can, discuss one-on-one.
Thank you.
Okay.
We will have a personal chat also on this number.
Definitely.
Thank you, everyone. I think Santosh, you can take it forward from there.
Yeah, thanks a lot, Akshay, for initiating this to take this discussion offline and to understand the concern that he has raised. So thanks a lot once again
Thank you,
for
Santosh, for inviting.
coming on this platform. And as always, India Energy Storage Alliance has been supporting our various virtual meetings that we are doing. So I once again extend thank you to you.
Thank you, Santosh.
For your association. Yeah. So moving ahead, we have our next speaker, Mr. Baiju Bhuvaneshwaran, and he is Director, DC Technical Practice at Kyndryl Solutions Private Limited. Before I hand over to him, a brief introduction to him. Mr. Baiju Bhuvaneshwaran leads the Global Data Center Service team, which supports the solution sales of Kyndryl's data center services worldwide, including data center design, DC assessment, IT sustainability, and IT discovery and relocation. He is proficient in design and build of physical infrastructure of enterprise modular data centers, containerized data centers, and telecom switching centers. Conducted tier compliance audits of data center as per TIA 942 and operational sustainability audit as per Uptime Institute tier standards. Support the customers in technical evaluation and vendor finalization. He was a member of the Committee for Developing Standards for Green and Sustainable Data Centers by India Green Building Council. He is going to share his views on pioneering breakthroughs in battery chemistry and technology. Over to you, Mr. Baiju. You can take it forward from here.
Thanks, Santosh, for introduction. Hi, friends.
Yeah.
Very good evening. So I think I'll just share the screen. Are you able to see my screen? I think there's some.
No, still it's not visible.
Yeah, is it
Yeah,
now?
yeah, it's visible now. Yeah.
Okay. Yeah, once again, very good evening, friends. Already, I think we are on top of the earth. As Santosh introduced, I'm from Kyndryl, and Kyndryl is a largest provider of IT infrastructure services, serving thousands of enterprise customers across the globe. Precisely more than 60 countries we have presence. And as we support all the across industries, precisely for the automotive companies, we support the acceleration to the modernization plans, as well as better connectivity and the cloud service. Yeah, so we support the battery industry for setting up the giga power plants, the communication between their critical operations, the data center setting up within the giga factories. All these are part of activities. So coming to our subject today, so I'll be touching upon the EV battery chemistries and some the latest technologies available in that. So the agenda will be, I'll be covering all these aspects, starting from the electric batteries to the battery management system and the charging infrastructure. So coming to the electric vehicle batteries, there is a key role in the battery for the batteries in the EV, because it is synonymous to the fuel system of an IC engine. So as we know, the efficiency of the battery, that determines the performance of an electric vehicle. And the batteries are pollutionless. Inherently, it is not polluting the environment, and it contributes to the sustainable future. Then comes the range. Range, of course, there is a fear or the concern among most of the users. So, which is again the manufacturers and the innovators or the researchers are working on improving the range of batteries or the range of vehicles. The range means it's distance it can cover in one single charge. So that and all is coming in the developing in future, and it is already developed. We have reached approximately 500 kilometers per charge in many of the leading manufacturers. So the battery application for EV. So batteries generally we consider the application like two type of applications. One is cyclic operation and another is a float operation. So generally float operation is nothing but we keep the battery for the standby operations. We charge the battery and keep it for when the main source is not available. That time we will be discharging and using that charge, and again when the power comes we charge it. That is the float usage, which is generally in our UPS systems or our starting car batteries or generator batteries. These are all coming the float operation. And cyclic operation is like it will be discharged and charged frequently, and it will be deep discharging can be done to 100% deep discharging is possible. Those kind of operations is suitable for our EV, wherein we need to discharge, the depth of discharge should be above 80%, and the longer span of life all will be expected in a EV operation. So float the float kind of application is for the EV. And why batteries matter? So battery is a very crucial component in any electric vehicle, because as I mentioned, it is synonymous to the fuel system of an IC engine. And this battery supports the propulsion or the momentum of the vehicle. It has the energy. It's the energy of an electric vehicle, and it supports the range. It decides the range of movement of a vehicle. Then the energy efficiency of the battery is generally deciding the performance of an electric car or electric vehicle. And EVs have very less moving parts. So therefore, the maintenance requirement is also very less for the EVs. And batteries as such, it's maintenance free. Most of the batteries used, the chemistries used in EVs are maintenance free and with very less maintenance and easy to handle. It can tolerate large weather conditions. So these are all creating the significance of batteries in the electric vehicle. And the last option is like grid integration and energy storage. This, of course, is not practiced, but it can be thought of in case of the grid stabilization requirement. The EVs can feed the grid and balance the grid when the grid is unstable. Some of the salient features of EV batteries. So most of these EV batteries are having larger lifespan. So 8 years of guarantees have been offered by many of the manufacturers now. And the safety, the EV batteries depend upon the chemistries or other ways also. The manufacturers are offering or confirming the safety of EV batteries much more than a lead acid battery nowadays. Though there was concerns earlier, now it is getting addressed. The performance of the batteries then. The performance of batteries, one of the key features in EV batteries is it can tolerate different climatic conditions. Though the batteries are very sensitive to these, so these batteries are packed or manufactured in such a way that it can tolerate the harsh ambient conditions on the road. Then specific energy. So the batteries, when you say the specific energy and compare with our IC engines fuel, the batteries, the percentage of energy generated out of 1 kilogram of battery is very less actually. But when you compare the efficiency of the engine or efficiency of the battery comparing to IC engine, efficiencies of the batteries are very high. That actually compensates the low efficiency of the IC engines. So the specific energy, when you say the batteries are low, but efficiency is very high. Then the specific power. So as we all know, the electric propulsion system has a better torque with the same horsepower. So this for a better acceleration, the batteries support, the battery chemistries support a better acceleration and high specific power. It can give power at a short period of time. And the cost. The cost right now is a serious concern. As you all know, the cost of batteries equivalent to a small IC engine car's price. So these are all the concerns and some of the features of EV batteries. And type of EV batteries, predominantly we have seen lithium-ion batteries are used in the EVs, and which is commonly used in EVs as well as energy storage systems. Then nickel metal hydride is another chemistry, other than the lithium. This is also having a long life cycle. And then the solid state batteries, which already Genco Solar has mentioned. These solid state batteries, they are going to develop in the future. So it is another development, and it will have more or higher energy density, and it enables the fast charging and improved safety comparing to lithium-ion batteries. Then the sodium-ion batteries are another development happening. This also because of the less expensive raw material or the components, this battery, sodium-ion batteries, will be bringing in a low-cost battery system, and we hope it would reduce the cost of EVs. Then the lithium-sulfur batteries. So these are under development now. Then the supercapacitors. supercapacitors are currently used in conjunction with the lithium-ion batteries or NIMH batteries to provide a sudden acceleration or the quick delivery of energy required. Those places, these supercapacitors are still used in some of the high-end cars. So when you say going to the basics, this is the basic chemistry of lithium-ion battery. We are talking about lithium-ion battery because this is the one predominantly used nowadays. So as every battery required cathode and anode and electrolyte. So here also the cathode is lithium cobalt oxide or lithium metal oxide, and the anode is made out of graphite. Originally it was graphite alone, and with later developments, the silicon doping is also done to increase the life of the anode. So, and the most important thing in this type of batteries are the separator between the cathode, anode, and the electrolytes. So the separator, in case if it breaches, then it could explode. It could cause an explosion within the battery due to the chemical reaction. So, as we know, there are multiple chemistries available in the market now in terms of lithium-ion batteries, such as LCO, that lithium cobalt oxide, then LMO, NMC, LFP, and the lithium nickel cobalt aluminum. So these are the different parameters compared within these chemistries. The most importantly, we focus on specific energy, charge rate, discharge rate, life cycle life, and the thermal runaway, at what temperature it will collapse. So if you compare that, we know that NMC and LFPs are the major one or significant one in among these chemistries, and predominantly used in the EV sector. So we will come to which type of batteries chemistries were used within last few years. So there is a study conducted by International Energy Association agency about the usage of batteries. So from 2018 to 2022, the selection of these batteries has been populated here. You can see the high nickel or the NMC batteries were used during 18, 19 up till 20. It was a steady growth of those chemistry. And post COVID, you can see the change happened. The LFPs gradually increased and started capturing the market or the chemistry. One of the reasons for this is the high cost of the metals or the minerals like nickel and manganese. So, and the LFP batteries commonly using the phosphorus, which is abundantly available, which is used in the agricultural industry as well. So so that availability might have been caused increased the use of LFP batteries in production. So one of the major factor of these lithium-ion batteries is the safety. So we have heard a lot of batteries busting or catching fire because of battery thermal runaway. So from I think last 4, 5, 6 years, we have heard about a lot of such incidents, and still there is a kind of fear among the users that lithium-ion batteries are not safe. Anytime it can explode. So considering all these the embedded BMS system, the battery management system, is introduced per cell. Starting from the cell to the pack, the BMS system manages the parameters of a battery cell. So it has multiple safety features here, like a separator, that fuse and vent, and the different safety function, communication layer. Everything is provided for creating the safety of the battery as well as the human operating these batteries. So there are the quality control and testing also introduced, and even the Ministry of Road Transport and Highways have mandated EMC testing of BMC as per the standards AIS 004, IS 16893, and they have been mandated the test reports from NABL accredited labs. That is for the quality control of the BMS system and the batteries. Similarly, for the batteries, all IECs and UL certification also followed by, complied by many of the manufacturers. And again, Ministry of Road Transport has made mandatory for the battery safety as well. So the battery management system, this is a vital component actually. This is controlling the state of health of battery. So this monitors the cells. In fact, it controls the temperature and inform the user through the communication protocols. So the communication becomes vital here. So we get the state of charge, state of discharge, or state of health. All these will be communicated to the main console, and the corrections to be done, whatever to be done, it will be done automatically, and the same will be informed to the user. In a car, you can get the details of the battery or the status of the battery, and warnings, alarms, everything will be visible. You can get through the Bluetooth in your mobile handset or on the car dashboard itself. Nowadays it is available. So these are the communication protocols, and the through the cloud it monitors. The large fleet of the cars can be managed or monitored through the cloud, the well-being of the battery as well as the EV altogether. So then comes the battery charging infrastructure. So now we have been seeing charging points at highways and artery roads as well. So now the number of charging infrastructure has been increased to cater the increasing population of EV vehicles, electric vehicles. So the charging station, the level 1 charging stations are for the household outlets for charging the the two-wheelers and the three-wheelers, or sometimes four-wheelers also, on a lowest charging rate. Then comes the level 2 charging stations, which is for public road and public usage, which will charge a little faster than the level 1. And then the DC charging, so direct current charging for the fast charging requirement. So this is also available currently on the market. So finally, this is my last slide. The main takeaway is that there are a lot of features, safety features and measures considered while designing as well as manufacturing the lithium-ion batteries. But we, as a user, we have to be properly monitoring and use the batteries or the vehicles to avoid the overheating, overcharging, physical damage as well. So overheating and overcharging is monitored by the BMS and will get the alerts on time. So we need to take proper action to safeguard the batteries and try to maintain the charge between 25% to 80% in a normal condition. And the fast charging is in practical conditions we have seen the fast charging is possible, but it should not be continually doing for every time. I mean, every frequent fast charging may damage or reduce the life of the batteries. Yeah. So this is this is the end of my slides. Thank you so much.
Yeah. So thanks a lot for this wonderful presentation, for touching on the battery chemistry, the technology, and the applications, and even the charging stations that are there. So if there are any questions, the forum is open. Anybody can unmute themselves and ask the questions that are there.
Only one question I have. This is Pramod from Genus. Sir, you talk about the cell level monitoring, the cell level BMS. Is there any cell coming in the market which has, which comes with along with the like cell level monitoring? I don't know.
No, this is the when I said the cell level monitoring, it is not one cell coming with in the market with the BMS.
Right.
I said it's a pack of battery. The batteries actually consists of a number of cells in parallel series parallel configuration.
Okay, then I got confused. I thought that there are cells which comes inbuilt BMS so that we can have a cell level monitoring also.
No.
Okay, no, it's not like that. Okay, thank you.
Thank you. Thank you.
So yeah, so thanks a lot, Mr. Baiju Bhuvaneshwaran, for joining this virtual meet and sharing your insights. Moving on, we have our next speaker, Mr. M.K. Srivastava, VP Sales and Marketing, Ensure Reliable Power Solutions Private Limited. Before I hand over to him, a brief introduction to Mr. Srivastava. Mr. M.K. Srivastava is a seasoned professional serving as the Vice President of Sales and Marketing, bringing with him an impressive track record spanning over 32 years. His extensive and diversified experience encompasses profit center operations, sales, service support, and distribution management, all within leadership role at prominent MNCs and large corporations. These organizations include Gujarat Ambuja Cement, Canon HCL Base Corporation, and Southern Batteries, Firefly Batteries. M.K. Srivastava is a well-versed leader who has effectively engaged with EPCs and OEMs to establish a foundation for the incorporation of cutting-edge lead acid and lithium technologies. His leadership extends to managing and inspiring a substantial workforce, driving organizational growth, and consistently exceeding customer satisfaction expectations. He is notably skilled in expanding distribution networks, facilitating deeper market penetration, and achieving substantial revenue growth. His rich and varied career highlights his commitment to drive business success through his expertise in sales and marketing leadership. He is going to share his insights on Ensure energizing India's future with lithium cell manufacturing. Over to you, Mr. Srivastava, and welcome you to this event.
Yeah, thanks a lot, Santosh, and a very good evening to all the audience over here, and thanks to earlier panelists and the keynote speakers prior to me, where I missed out. My apologies for missing out Mr. Pawan session. Got stuck up with some meeting, but a very deep insight and very informative session we had through Mr. Sai Charan of Jinko on the ESS. We had ISA, which has shown a lot of insight on the government policies to propel this industry in this ecosystem. And right now, Mr. Baiju has given what about the basics he has tried to touch upon and what need to go forward on developing a better ecosystem to drive this industry on the mobility. And thanks to, not to mention Ms. Sapna for initiating this. Very good evening once again to everyone. I won't take much of time because already I think we have extended our timeline. I will just try to share my screen. Where's my screen gone? Yeah. Is it visible to everyone?
Yes, sir, go ahead. Yeah.
Yeah, thank you. So I will won't take much time. I won't talk much about the data and the numbers. I think the previous keynote speakers have shared enough data how this industry is going to move forward progressively, constructively, in a collaborative manner, and with the better coordination from all the stakeholders within the ecosystem. So we, as one of the, I could say, upstream of the market, where we are ensure as a company, I would take you to the journey, like what exactly the company is all about and where we are heading forward to establish the lithium cell manufacturing. We were one among the earlier participant in the previous PLI ACC scheme. For some reason, as results were shared by Mr. Akshay, that for some reason, out of 10 participants, only 4 qualified and 1 was rejected for obvious reason. So again, 20 gigawatt of window is open. So probably we could see a lot of participants coming into it. As far as Ensure, I would just share what Ensure company is. This company is a wholly owned subsidiary of RCCL, which is basically a Ramalingam construction company. And this company basically is having a rich background, experience background of infra projects, especially into urban development management of and engineering and constructions of building, highways, marine structure, electrical infrastructure, and irrigation project across the Indian territory. And we have also done a big toll road in Tamil Nadu, World Bank funded annuity road project. And we are also doing the green corridor in the Chennai-Bangalore National Highway Expressway, which is coming up, and one more HAM project we are doing for NHAI, recently announced in Karnataka. So Ensure is offspring of, you can say, RCCL company some 6 years back, with led by one of the director called Mr. Chandrakant. And Mr. Chandrakant has a vision of doing something good in energy sector. So we ventured out through Ensure 6 years back in establishing the first of its own kind in utility sector for energy smart meters. So in the one utility in Karnataka, we have completely executed, installed, and maintained for last 6 years, and it is under the renewal. To take up in manufacturing, we have identified a place near Bangalore called Malur, where we'll be establishing our first gigawatt hour over there, and then taking it further to 15 gigawatt hour in phased manner. We have acquired sufficient land bank over there, close to 80 gigawatt hour, and we are in the process of acquiring another close to 60 in the same vicinity for further expansion. To enable this, we have coordinated and established our partnership on the technology side for material research and advancement. We have tied up with ARCI, and for our technology transfer, we have tied up with a company called CPS, which is Continuing Power System in USA, based out of USA. Through that, we are going to establish this first phase of gigawatt hour manufacturing. This is just a slide on the financial of the company, our parent company, which was $200 million last year, which was up from $140 million in the preceding years. They have a big workforce of 1,900 plus employees, and they have a very good asset and in-house equipment because they are into big infra projects, close to $65 million worth of in-house equipment and machineries. This is what I briefed you. We have already executed this energy smart meter for BESCOM. And we have got almost migration of 3 lakh domestic consumer from analog digital meter to smart meter in Bangalore and Mysore also. Now it was two years back, we decided to venture into the space of establishing lithium cell manufacturing. So as I mentioned, 160 acres of land near Bangalore. We have already done 80% of land parcel. This is somewhere around close to 45 kilometers from Bangalore International Airport. We were the first among who has got the approval from a state high-level committee to commence the factory within principle deemed conversion of entire land parcel along with the survey. We have a good panel of advisors from various sectors, industry expert, chemistry experts, manufacturing expert, and also on the strategic business experts we have on our panel who are going to take it forward that this whole project definitely will be a successful project. So we are blessed with that, the panel of our advisory members which we have on board. We have already signed with Karnataka government for investment of $130 million commitment in the first phase. We have also got approval for grant under ESDM and EV policy. Ensure has been to understand the market, to be with the market, to understand the dynamic of the market, to create the pipeline in the market. We ventured into, as Ensure, to import the good quality cells and be a feeding conduit to the battery pack and some OEMs. We have been successful in the last couple of years. We have established a turnover on around maybe more than 100 CR, and it's going strength to strength. Now, since we are in the verge of establishing the manufacturing, so we are focused on our design, which we are going to manufacture. So we are trying to promote and establish a pipeline and coordinating and collaborating with the stakeholder in this ecosystem down the line with the battery pack manufacturer and some OE selected for promoting those model. As I said, our parallel activity in the ecosystem also has to venture out into the BSS where there is no conflict of our existing business. So we are one of the first in Karnataka to integrate solar on the grid with BSS. So we have bagged a prestigious order of 1.5 by 4.5 megawatt hour, which will be established in Pavagadh Solar Park, which everybody is familiar with, one of the biggest solar park in India. And I think this project value is somewhere around $5 million. We're also palling with another close to bagging another in Tamil Nadu, similar kind of this thing 1 megawatt by 3 megawatt hour with 10 years of O&M, which also we have also executed one Southern Railway for all the platform lighting and signaling. We have converted from the existing conventional lead acid to a lithium backed energy storage, which also got approved and under close to, you can say, the final testing phase in 3-4 railway station in the southern sector. This is some pictures where we have signed up with the Karnataka government for investment to be made in Karnataka. This is our partnership with, as I said, advanced mineral research and material research with ARCI, which comes under Ministry of Science and Technology. And also this is our partnership on the right hand side, you can see is our US partner CPS, Continuum Power System, for signing the technology transfer with them. Now this is what for all the allied members over here, this is what the two models which we are going to come up as a manufacturing. 30H LFP pouch. I can share the things with Santosh. Santosh can share with you if required. You can have an access to that. Another one which we are going is 15Ah LFP large cylindrical cell, which is having a 15Ah 3.2 volt. So because this model, what we understood is a perfect model, is a crossover model 15Ah, which perfectly fits the electric two-wheeler. Some models I will not say, because in this industry, one model, one format doesn't fit for all. But yes, we have to see which can serve the larger segment of the application. So this 15Ah, it's an upgraded model of 32700, which was prevalent in India on the LFP cylindrical. And this with higher volume density of 400 plus is a better model than the predecessor of any pouch, prismatic or cylindrical of LFP. So as of now, this 15Ah in 33140 format and form factor is the best model to create the solution for all the low end. I think up to 15 kilowatt hour to 20 kilowatt hour. This model can be a very good option for all the application side as far as which we are witnessing, and good transition in the market. So with that confidence and conviction, we have decided to go establishing the first main plant of establishing 15 AH LFP large cylindrical with 1.5 gigawatt hour first phase. And this pouch which you saw, because India is in very nascent stage, but we see a lot of promises as a pouch as an option for going in the mobility side, 30Ah pouch. And we are establishing the pilot line, which is already equipments have arrived. I think in a couple of months, maximum 3 months, it will be commissioned. From there, we can keep on feeding this product to the market made in India for validation, for product approval, for testing. So to create the demand and get familiar with, usage of pouch cell. So this is our plan as far as cells are concerned on the manufacturing side. This is our design, our layout, you can say, of the land bank. You can see that in the center, the highlighted patch, that is the one the first phase will come. And in the phased manner, already we have allocated how the expansion will happen. Our management has also a very good options which we are thinking forward as a, you can say, innovative idea, where we can approach any OEM if they have that scale of demand. We can also establish dedicated for them separate line, separate units. So this is how the benchmark has been. We want to become, as always management refers, that we want to become a Foxconn for many OEMs. They can approach us, we can jointly address that, we can set up dedicated to them, any capacity, any format, any chemistry they want. So this is the idea behind the approach of management forward moving in this manufacturing space. And this is another which is very close to our director's heart, is to create a open source research hub. And we are very keen on establishing a world-class facility to set up an R&D where all people who have research fellows, who have an idea, who have a zeal for creating some innovation in the chemistry side, new technology, upgrading, upscaling, any innovative idea in that they can approach us. We are setting up this potential platform them with equipped with all the latest equipment, testing equipment, measuring equipment, analytic equipment, electrical, anything required to make a technology successful. We can give them this space. They can come and work with us. So this is one of the, you can say, a novel idea which management is seriously working. We are infusing a lot of funds in that to have the latest world-class lab over here. So this is one of the new things you can see in this Indian market. These are our key members, as our director on the topmost, our CFO, myself, a project head, our plant head, all our people collective. I think we have close to 300 years of experience if you put back all of them. So with this, I would like to put rest my presentation. I'm open to any question because already we have exceeded the timeline. So yes, thanks everyone for the patience and the listening and watching this presentation. Thank you once again, everyone. Thank you, Santosh. You can take it forward from here.
Yeah, thanks a lot, sir, for this wonderful presentation, giving us an insight into how Ensure is moving forward and the vision and your future plans that are there. So, if there are any questions, then participant can ask. Okay, so I guess we come to the end of this session that is there, and one presentation that is there with us is going to be done by Mr. Rahul Bolini. Before I hand over to him, a brief introduction. Mr. Rahul Bolini is the founder of Bolini Energy and boasts a compelling journey in the energy sector. Prior to embarking on his entrepreneurial venture, he dedicated 6 years to serving as an independent lithium-ion cell R&D consultant. During this tenure, Rahul collaborated closely with prominent companies from India, America, Europe, and Japan. He garnered invaluable hands-on experience in lithium-ion cell engineering and the entire fabrication process. Rahul's education background is equally impressive, having pursued a degree in energy business and finance from Pennsylvania State University, USA. His academic pursuits align seamlessly with his practical experience, underlining his commitment to advancing innovation and solutions in the energy industry. He is going to discuss on the latest battery market trends that are there. So over to you, Mr. Rahul, and welcome to this virtual event.
Thank you so much. So I think we are, like Mr. M.K. Srivastav ji said, we are already past the allotted time, and so let me also be quick, okay? Yeah. So I need to share the screen.
Yeah, just give me 1 minute. Yeah.
Sure.
You can share it, yeah.
Okay, is my screen visible?
Yeah, go ahead, yeah.
So, hello everyone. I'm going to talk about EV market trends for batteries. So generally, these are the factors that decide which type of cells to use. Gravimetric energy density, which is directly related or proportional to the weight of the cell. Volumetric energy density, which is pretty much directly, dependent on the dimensions of the cell. And also, this is very important when you want to pack in as much energy as possible. And the charging speed, so different cells have different charging speed capabilities, and depending on what's suitable for them, people take a call. And discharging power, which is again the discharging speed. So this is also again looked upon based on how the battery needs to perform in an electric vehicle. And then operating temperature and derating values. So I'll talk about derating values in a minute. And then the cycle life, as everyone must be aware that different type of batteries have different cycle life. And I was listening to Mr. M.K. Srivastav ji earlier when he was saying, batteries are expected to be lighter also, and then, you want a more cycle life also. Electrochemically speaking, that's not possible. You either have to choose one. So if you want to put silicon doped graphite and, you want to reach LFP in 200 watt-hour per kg, there is availability of such cells. So I'm traveling across the countries. I've seen such cells in the R&D, but you have to give up on the cycle life. When you take up the silicon graphite anode, the cycle life is lost. That is one of the reasons why nobody uses that in LFP. And also you could do that by going with 3 micron copper, because copper also has a decent amount of weight. You could do that. Then you cannot say I want 10,000 cycles, not possible. So I rightly agree with him. And coming back to this one, yeah, cycle life and cost. So LFP has a different price, NMC has a different price, and then there is NCA, and then newer things such as sodium ion and LMFP have just hit the market now. So we'll talk about that. I'll be covering that in the last slides. Yeah. So this is what is a derating value. Derating value means how the battery would, what is the best possible performance that can be expected from the battery in terms of C rates at different temperatures and at different state of charge. So as you can see, the best kind of thing can be when the battery is fully charged and it's in the optimal conditions close to 25 degrees. As the battery is moving to a higher temperature, then the discharge rate would come down. Again, as the battery is discharging and coming down close to zero, the discharging power falls down. That's why whenever in your cell phone or in a car or a scooter, you would see that when you're at the battery low level, the performance of the vehicle or the phone or something is reduced. That is because of the derating value. So anybody who wants to build a battery pack, they consider this to try to understand and compare with other cells. So these are the general Indian EV cell trends, which is pretty much today you will see. So there's about almost 500 plus battery packers in India. I can tell you more than 450 or 90% of them only use this kind of 3 cells. And again, 18650 is the most oldest one, which is pretty much used because of its small size. It's modular. You can pretty much make any kind of packs. And then 100AH, very popular in the 3-wheelers and small energy storage. 33140, like Mr. M.K. Srivastava was talking about, that has already hit the market. And in fact, Ensure is one of the biggest traders for that cell. And there are some other companies also working on that. Now the market has kind of moved on already into it. And let me talk about the use case scenario. 18650, very popular for low-speed 2-wheelers, high-speed 2-wheelers, and small capacity solar street light. 33140, very popular for low-speed 2-wheelers, high-speed 2-wheelers, solar street light, small capacity battery for L3 vehicles, say 75AH or 90AH, people want to use this, and also electric cars. So if you look at Tata Nexon EV, it uses this kind of cell. Let's look at 100AH cells. So 100AH, very popular in L3 3-wheeler, which is basically the e-rickshaw. Also L5, where battery is expected to be close to 200AH. So pretty much 2 cells in parallel does the job. And then small scale ESS and low voltage, high voltage. So small scale would be 51.2 volt 100AH kind of pack, all the way to 480 volt or 384 volt high voltage system with again 100AH or 200AH. So this is the present market trend. Pretty much, like I said, 90% of the battery packers are using this. And then the latest EV cell trends. So the latest trends in India emerging is larger cylindrical cell, pouch cell, and larger prismatic cells. So let's talk about this in a little bit detail. So larger cylindrical cells, again, I would like to divide that into 3 categories. Although 21700 is very, very old, companies like Tesla and few other companies have been using it for more than 5 years. And then, but in Indian market, it is just hitting, and all the premium scooters that you see in the market, Ola, Ather, TVS, and Hero Vida, they pretty much use this. But other than these 4 companies, not much of this is happening. Also, cost is a contributing factor why it is not taking off. But now people have understood its importance, how it is able to, in a small footprint, provide higher energy density. So people are considering this. And 4680 NMC, this was first introduced by Tesla for their cars. And also, there are other players in China who are manufacturing this. So this is also something people are just thinking about it, testing it. This, you will probably get 26 AH of capacity in 4680. 21700, about 5 AH. And now the market is doing final level testing for 5.8 AH. So very soon you will see 5.8 AH cells commercially available. And then 4680, also LFP available 15 AH. This is popularly made by BYD, and a few other companies are also looking at it. And then 4135, it's a 28 cell, and then 34189, which is again a 28 cell. So these are also considered newly in the market. It's a new kind of trend, especially for low speed and high speed 2-wheelers here. Now let's talk about pouch cells. So pouch, again, LFP and NMC, they have their own importance. Low speed and medium speed, they want to use LFP. Ultra high speed, sometimes they want 3C cell, and pouch can be about, LFP can be about 2C, which should pretty much take care of most of the high speed. But ultra high speed, maybe sometimes they want to look at NMC. but NMC comes at a cost. It's expensive, it's less safe, the cycle life is less, but still, for various reasons, it is kind of preferred in some of the applications. And then again, if you look at L3 category, which is the e-rickshaw, maybe 3 batteries in parallel or 2 batteries in parallel, 80, 90, 100 Ah, people are working on this. And also, small scale ESS, again, smaller ones like 51.2 volt, 30 Ah, all the way to 480 volt, 30 Ah or 50 Ah, people are looking at this. And this is proven to be very encouraged in the market now. And then electric buses, many of you would be surprised to know that a lot of electric buses in India are actually using NMC pouch cells. And it is mostly a mix of NMC and LMO. NMC by itself will be very, very unsafe. So it's a mix of NMC and LMO, which gives a little bit of stability, a little bit of high cycle life, but you will have to give up on the gravimetric and volumetric energy density. LFP prismatic cell 206 is just entering the market, especially the L5. Like I previously said, people are using 2 into 100 Ah in parallel. Now 200 Ah is being tested to go into one cell in parallel configuration. It is always preferred that you have the lower cell in parallel for a better system architecture. Yeah. So this is one of the reasons why two-wheelers who were using 6 Ah LFP are shifting to 15 Ah, like I was talking about, the 33140. So for a 30 Ah pack, where you'll have to use 5 cells, now you can just use 2 cells. And the 230 Ah EV cell is again very popular for electric buses, very popular in China, India. I saw one company testing it and proven to be good. It's about 4 kg, 4.2 kg cell. And yeah, with a good cycle life of 4,000 around that. Yeah. And 280 Ah, I know, although this is about EV trends, I would like to add the 280 Ah popularity growing, especially for ESS market. So 280 Ah is the highest capacity cell commercially produced today. It also happens to be in all the containerized batteries that one would see, especially with the liquid cooling kind of systems and all that. Yeah. And let's talk about the new upcoming technologies. So there is LMFP, which is a lithium manganese iron phosphate battery. It comes in various variants depending on the ratio of manganese and iron composition. This chemistry is getting popular because of higher voltage than LFP. So its discharge capacity is pretty much similar to LFP, but the voltage, the potential is on the higher side. So it is garnering a lot of attention. In fact, some of the Indian companies are doing trials with it. And it is expected to take a little bit of market share in the future. So this is, I want to make one thing very clearly. This is not a replacement for LFP. This is a replacement for NMC. Yeah, because the voltage is kind of similar. And when people want to focus on a little bit of higher safety, then they go to LMFP. Yeah, but this is no way actually considered as a replacement for LFP. And then it is expected to be cheaper than LFP when it hits the mass manufacturing, which would be down the years, not right now, because you know the higher potential and similar material cost, and manganese is not very expensive. But it has a disadvantage that the voltage is not very gradual. It has something called a double dip kind of thing. So it requires a specially designed BMS. So let me show you how the voltage looks like. So on the left, you have LFP, and on the right, you have LMFP. Yeah. So the voltage is not very stable. Let's talk about sodium battery. Sodium-ion battery, a lot of people, in fact, one of the earlier speakers was also talking about that it's being developed and all. In fact, I'm testing some of these cells also. Like Mr. M.K. Srivastav said, 3 voltage, yes, 3.05. Good cell. But to be honest, nothing can be spoken about the cycle life. So even if someone wants to put it in PLI or take it to a very high cycle life, I would have my own suspicions because it's a very new material. Nobody has real data of even 3,000 cycles. So maybe, you know, looking at very high cycle life for this would be a little bit difficult. Also, the volumetric and gravimetric energy density of sodium-ion batteries is not par with LFP. And it will take some time to catch up. But yes, it is supposed to dent the LFP market in the storage industry. And also some companies are hoping to bring this in low speed EVs, but nothing more than that. Not really for cars and all that. Yeah, maybe low speed cars, but yeah. And a few companies such as Faradion acquired by Reliance and Altris, they were they are very close to commercialization, and some companies in China have already done it. Samples are already available for testing. Like I said, advantages would be that it's cheaper, supposed to be cheaper, but it'll have to go to that kind of scale. And sodium is abundantly available in the ecosystem. It can have higher cycle life, like I said, potential to have, but today not yet proven. And lithium-ion batteries use copper, negative current collector. This uses aluminum. So again, aluminum is cheaper, so helps in the cost cutting. Disadvantage, like I said, lower WH per kg and WH per liter. Lower nominal voltage also. That means to make the same kind of voltage, you need more cells. So again, the BMS needs to be a little bit tuned, redesigned, and all that. And technology yet to be commercialized at a very, very giga scale. Today, it's only in mega. So pretty much, thank you. Any questions? I'm open to taking questions.
If there are any questions, then participants can ask actually. Okay. So thanks a lot, Bolini, for this wonderful presentation. And with this, we come to end of our session, the virtual battery meet that we had organized today. So thanks a lot to all the sponsors, the speakers, and the supporting associations and participants for joining this virtual meet. As I have mentioned, this is the fourth installment in the series of virtual events that we are doing this year, and there has been a tremendous response and interest from various professionals and key leaders to these virtual events that are there. We have these events are being supported by India Energy Storage Alliance and India Electric Mobility Congress and Smart Energy Council. And this particular session for today, the virtual EV battery business meet, has been sponsored by COMSOL. So we thank to all the association sponsors and all our speakers for this today's session for joining us and making this event be successful. We are planning more of such events, and we look forward to more of such interactions and networking opportunities in the future. Thanks a lot. Thank you very much. If anybody wants to add anything, then you can add it, or else you can call off the session. Okay, so thanks a lot. Thanks a lot for joining. As I have already mentioned, this session was also live on YouTube. So we will be sharing the link with you all. So anytime you can access this particular 2 hours of meet that was there at your convenience. You can reassess and revisit the different presentation that was there. So thanks a lot. We look forward to your cooperation and your support. Do like our LinkedIn page and also follow our YouTube channel to get regular updates from the solar, renewable energy, electric vehicle, and green hydrogen energy. Thanks a lot. Thanks once again to all.
Okay, thank you.